Share content. Yes, FRC Effective Strategic Design Presentation. So what is strategic design? I'm sure you're all incredibly excited to know. So this is the engineering design process, right? Strategic design is effectively how we approach the design process to achieve the optimal result. So if you want like a really accurate description, this would probably be it. Strategic design is the application of future-oriented design principles in order to increase an organization's innovative and competitive qualities. Or to dumb it down a bit, the effective identification and analysis of a problem with the intention of meeting a set objective at a given point in the future. So we mostly tend to focus on the defining, identifying, and brainstorming parts of the process when dealing with strategic. And first step is generally just objective. Our overarching objective is just, have fun. Pretty fun, at least in my opinion. So our goal is winning. So how do we win, right? That's generally a more accurate description of our strategic design goals from any given year. How do we win in that game? Okay. Slides. I don't know. That works. So the single greatest factor on a team's individual success is the effectiveness of their strategic design, at least in my opinion. So this is 1678's lead technical mentor, and just overarching lead mentor, really. Mike Corsetto. He developed the original blueprint we use for strategic design presentations. He's a pretty cool guy. But yeah, 1678 really started to get good in around 2012, 2013-ish. They now currently have a 7 years Einstein streak that began in 2013. They won their first regionals in 2013. They appeared on Einstein's finals field in 2014. So they're a pretty good team. Their entire strategic design philosophy can effectively be summed down to this. Although I'd argue they have their own drivetrain at this point. So moving on, there are 4 main principles of effective strategic design. These two are considered the most important, but let's go over these first. Consistency and robustness. They seem like they'd be the exact same thing. I think of it as more of a chicken and the egg situation. A robust robot tends to have more consistency because it is less likely to fail. But a robust robot does not necessarily have more consistency. Consistency is just how much a design is capable of repeating a function over and over again. You can have a robust design that's just not good at achieving its function, and therefore isn't incredibly consistent. Robustness is just how much it can keep to its original functional design, rather than keep to its design goals, which is really what consistency is. The real premise that strategic design tends to focus around is effectiveness and simplicity, and just the balance between the two. So we are going to detail that more later anyway, so I'm not going to go into more detail about that right now. So a lot of top teams have made rules for strategic design that they follow from year to year. I picked one of the best ones from teams like 1114 and 1678. So here we go. Here's some quotes. I'm just going to make a disclaimer now. Well, you can read these if you don't care. There's not an incredibly large amount of text going forward from here. I chose to focus morely on, using pictures and data to paint an image rather than writing it out for people to read. So, just pay attention, I suppose. First rule, build within your limits. This is from Karthik Kanagasabapati. He's the head mentor of Team 1114 Symbotics. They've won a championship back in 2008. They're consistently a top-tier team. They were 2014 Einstein's finalists. Einstein's is the championship finals field, by the way. case you were confused by what we were saying. So, yeah, he's pretty qualified. He was also the head of the VEX GDC for a while, and the head of First Canada for, I think, right now, actually. So, he's pretty deep in the competitive robotics space, and knows a lot about this, just in general. So, now on to the meat and bones of the presentation. Which one of these robots do you think is better? Just like thoughts. I don't know. Anyone want to guess? Here we have a robot that clearly doesn't have a turret. It's Tallbot. These are both infinite recharge robots, so this one can't fit under the trench. This one appears like it could probably fit under the trench, right? Full with intake on both of them. One of them has a turret. The other one doesn't. And over that, which one of these clearly seems like it would be the better robot? I don't know, Kashyap. Do you want to answer? I don't think anyone's going to go ahead and do that.
Well, I mean, if we're basing this off the principle that you stated last time, then I think they're both good robots because both teams decided to build based on, I guess, what they had or what they knew they had the ability to build. I honestly can't tell if the robot on the left is a 2012 or a 2020 robot.
It's not 2020 bot.
Okay.
Yeah. It looks so much like 1717's 2012 bot, though. Like, just without a swerve.
Yeah.
The mechanisms are unironically the same.
But I just say that, I mean, I like to just, I guess, butt in general if I'm talking already. But, so, Kartik said, build within your limits. And I don't know if you're going to expand on that, like, in the next slide or so. But I'd like to go into a little bit of at least my own experience on this team with, like, what that means. So, in FRC, right, you're going to see, like, pretty similar, I wouldn't say pretty similar challenges year to year, but you're going to see challenges with, like, recurring patterns or themes every year. Like, oh, pick up a ball, or even as simple as lift something, right? And if you're new to FRC, or if your team hasn't really attempted one of those challenges before, something as simple, that sounds as simple as lift something, is like a process that is going to take time to iterate and develop on. Like, I remember in 2018, our team made our first elevator in like 7 years or something, and we thought it was going to be a simple, okay, we're going to make an elevator and it's going to be good. And that's an example of what I guess I would say that we overstepped our limits, because the elevator that we designed and intended to build was pretty complex, like a shifting the 2-speed transmission originally, and like a really weird cascading string system, quite honestly. So our goal that year was we wanted to build a robot to win, right? But the robot that we designed, quite honestly, looking back, was a robot that, even if we had perfectly designed, like on time, was a robot that we probably would not have been able to manufacture on time given the machining resources we had. So to build within your limits is to like consider the capital resources you have, whether that be people that have knowledge about how to design certain things, whether that be how to design, whether that be from designing them in previous timeframes or just like having the understanding of the problem to be able to design it, as well as your physical resources. Like time is a big one. FRC used to be very limited time-wise. This season's going to be a little different with, I guess, we have now until April, as well as like challenge change. But time is a big one, as well as money. If you're planning to use like sensors or, I guess, fabrication resources that you don't really have access to, well, you're out of luck then. You need to consider those kinds of things while working on your design. Yeah, that's basically what build within your limits is.
Yeah, luckily on 3256, we're pretty well off as far as machining resources goes. I can't think of a single part on either of these robots that we couldn't make. Like,
Yeah.
Unironically.
Over the
Yeah.
past couple of years, our machine shop, I would say quite a lot thanks to the efforts of Mr. Huber, has increased a lot from one manual mill to we now have a CNC as well as a couple of laser cutters, which means that our limits have expanded. And this season actually was an example of a season where I would say that we almost built a little too well inside our limits because we didn't really have an understanding of how to fully use the resources that we had. So whenever you're working on a project, you want to be able to maximize the use of the resource you had, right? But because we didn't really have the knowledge or understanding of how to use the CNC until really later in the season, as well as how the fact that we were working with our laser cutters the first time for prototyping, we weren't really able to maximize the usage of our limits. But as we move forward, those are things that we're going to be practicing with you, how to use the CNC, how to use the laser cutter, so that every successive iteration of our team gets better at using the resources we have, so that our limits effectively widen.
Yeah, but from a purely competitive standpoint, let's look at both of these two teams, right? 973 here kind of clearly seems like it would be the worst team. Like, in terms of functionality, it can't go into the trench, can't aim automatically because it doesn't have a turret. It can feed from the feeder station directly, but it's a bit jank, unironically. So it seems like 973 would do worse, right? When we look at the statistics, and yeah, Citrus Circuits did fail early on at Los Angeles North, just a disclaimer, but the way ELO works, this wouldn't have actually really affected them as long as they had played optimally for the entirety of day 2, which they did. And even if matches in Los Angeles North, right, before 1678 had any communication issues whatsoever, 973 was already doing better from an ELO and OPR standpoint. So it can basically be brought down to they had a more consistent endgame. The drivers were better. They were more consistent throughout. They were generally better at almost everything they did. Citrus Circuits did better, obviously, in auto because they could take advantage of their turret, whereas 973 just didn't have a turret. But past auto, it begins to skew towards the gray bots, where their higher consistency and robustness in gameplay just give them a huge advantage, almost double the endgame OPR. So, yeah, moving forward, rule number 2, maximize functionality, minimize complexity. This isn't a direct quote from Karthik, but it's effectively what one of his longer statements boils down to. So, yeah, let's do another one of these. Which one of these two robots do you think did better? So here's a nice trick to just simplifying a robot's complexity in FRC, at least. There are similar methods in industry that I don't think fit nearly as well. In FRC, we can modify them to work to our specifications, right? How many rotary joints does it take from deployment to end function, right? Here we have one, and it's just for deployment. We also have a prismatic joint for our elevator, so 2 joints in total before we get to our end effector. Whereas on this robot, 254, right? We have a turret down here. Probably can't see it, but we can see the wire chain down here. We have an elevator, we have an arm, then we have a wrist on the end of that. So we have 4 different joints before we finally get to our end effector, right? Double the complexity. So which one of these, just looking at them, what do you think did like better? I'm not gonna wait for anyone to answer this one, because truth is, both of them just did incredibly well, and they each failed in their own specific areas. This is where it comes down to, again, simplicity versus effectiveness. 2056 did the bare minimum to achieve the challenge at hand, right? Just 1 for deployment, and then end effector. Just the absolute bare minimum necessary. And they did pretty well, right? They had the highest OPR out of any team in the world for the entirety of 2019. But they didn't end up making it to Einstein's, and they didn't end up making it to Einstein's finals, whereas 254 managed to do both of those things. However, if you look at 254's early designs, you might note that this looks pretty different compared to that. 254 put so much time and effort. They had a turret that worked and whatnot, a complex arm mechanism, so that they could score around defense, that they honestly didn't have enough time to perfect an end effector. I mean, this is the best team in the world, arguably, we're talking about, right? They have 4 championship wins. They have 56 regional wins, the highest in the world in both championship and regional wins, right? At this point, they had been winning championships for 2 years in a row. They won both 2017, they won 2018. So they're incredibly good. If any team could manage that, it's them. But arguably, they overreached, and their final robot didn't have many. Their final robot at BAG didn't really have many of the functionalities they wanted. Now, they managed to get those on for championships, but they didn't end up winning. So take what you will from that. 2056 kind of made the opposite mistake, where they had a really nice and simple robot, but effectively, they ended up being done in by heavy defense at both Canadian, the Ontario District Championships, and Detroit World Championships, where they didn't make it to division finals because heavy defense kind of just did them in. And they didn't manage to win Ontario because, again, heavy defense kind of did them in. 254's multi-axis arm was pretty capable of scoring around defense, or at least getting into a position where they could push at defense while still scoring. So while they may have overreached a bit, 2056 just might have not reached enough. So back to the point, you want to maximize the robot's functionality to do your strategy as effectively as possible. You also want to make sure you're not going too complex, because that can backfire pretty brutally. Now, both of these teams did do incredibly well, so they're maybe not the best examples for this, but they also just had incredibly unsatisfying losses by the end of the season. So take what you will from that. This one is funny. Anyone want to argue against this? I'd be happy to entertain that conversation. But anything that moves sideways is currently a waste of time. Kaushik is putting his hand in his head.
Okay, so I'm just gonna I guess qualify this one or explain what this means to newer members. So in FRC, right? Because there's similarity from year to year, I guess there's a pretty well-defined meta on or understanding of how teams have designed in the past. So this is getting a little bit, I guess, putting the cart before the horse. But one of the things that we're going to explain later on is more about drivetrain design, because obviously the robots need to move, right? And one of the most common drivetrain styles in FRC, and the one that we've used every year our team has existed, is something called West Coast Drive. Yeah, you can pan to it. All of those robots have it too. And basically, not to go too in depth into it, the idea is you just have wheels on both sides of your robot. There's a central gearbox that on each side of your drivetrain, and there's some method of power transmission from the gears to the wheels that makes the wheels on each side move. And if you have wheels on both sides, that means if both are going in the same direction, you can move forwards. If they're going in opposite directions, you can turn. And it's basically if you think of how a tank works, if you've ever seen a tank, it's also called tank drive. So yeah, that's how a lot of teams choose to build their drivetrains, because one, it's quite honestly pretty simple to design and build. Our goal is actually to have each and every one of you here to design your own by the end of the semester, if not by the end of November, which might sound daunting now, but I guarantee you, with like the workshops you're going through, you guys will definitely be able to probably do it on yourselves. So yeah. Now, what anything that moves sideways is a waste of time means is that because of like literally the probably thousands, if not over 1 million of like man hours of time spent on basically perfecting this one type of drivetrain by like the hundreds or I guess thousands of FRC teams around the world that have used this design in the past, choosing to build a different type of drivetrain, specifically the one that's referred to here, like a Swerve Drive, which is a type of drivetrain where you can move omnidirectionally, like in any direction around you, and like spin, is less valuable, or maybe like the added value of doing it is not worth the cost of time required, is like the idea here, which is like, I guess what Sadesh covered. As much functionality for as little complexity is what you want to aim for in design generally. And I'll go into like a quick explanation of what a Swerve Drive is. So a Swerve Drive, let's say you have like a box, right? And each corner of the box, you have these little, like an office chair almost, these little wheels that can pivot around 360 degrees. Every single one of those wheels independently can drive, right? So that means that robot can like move in any direction. It can orient itself while moving, and obviously for like a robot that has to go around, like pick something up and put it like at a higher place at something the opposite direction. Like if you think about it, a robot that can reorient itself while moving to a point, like sounds really good, because it is. Like strategically, if you want to reduce the amount of time it takes for you to go somewhere, pick something up, turn around, and then put it somewhere else, you want to be able to do that turn action while also driving forwards, right? But moving back to like our two earlier points, the amount of work that needs to be put in to make a functional Swerve Drive is pretty insane, which is why a lot of teams choose not to do it. But a lot of teams also do choose to do it. And I guess it really depends on what you believe your limits are. I know when Sadesh joined the team last year, he at first really wanted to make a Swerve Drive because, for one, it's a really cool thing to make. I mean, I think later in the presentation we can actually, or on a later day, we can cover more about how it works. But overall, yeah, I think the point that Sadesh is trying to illustrate here is just you don't necessarily need to worry about the Swerve Drive because the West Coast Drive covers all of the functions that are necessary in most strategies. Because like, as Sadesh said earlier, strategic design is you want to think of like a strategy or an approach to how you're going to meet your goals in competition, right? And for most teams, the West Coast Drive meets all of their strategic goals. It can drive place to place. It's extremely reliable. It can move fast or slow if you have a shifter, for example. It basically provides a lot of flexibility. It uses up less motors, so you can spend more time on manipulators, which is why that like phrase, I guess, anything that moves sideways is a waste of time, like became a thing. All right. I'm sorry if that explanation was like a little long-winded.
Nah, that was brilliant, honestly. It saved me a lot of time talking about the exact same thing in my gravelly voice. But yeah, honestly, 254 best team in the world, run West Coast Drive since their conception. Like, and as far as tanks go, 2056, arguably the second best team in the world, also has run a tank drive literally every year since their conception. Reminder, 2056 was winning regionals their first year in play. As a rookie team, they won all the regionals they played at. They didn't lose regionals until 2016, and then they were Einstein's finalists in 2016. Like, unironically, 1678 and 973, arguably top 10 teams too. West Coast Drive, for a majority of their years, 973 tried Swerve early. They abandoned Swerve because they decided it wasn't utile enough. again, we can rock out a West Coast drive in our sleep. We can get it done by the end of week 1. We can mount whatever manipulators we want to it, and we'll be good, right? Swerve takes time. Swerve takes energy, and honestly, we don't need to put in that effort, because if we can do everything else effectively, we're going to be fine anyway. Moving on, since I think we've talked about this a good bit. Touch it, own it. This is a bit more of the intrinsic design part, right? We've gone over West Coast drives now, so we're well into this bit. Who said this? Honestly, I don't. Anything that moves sideways is a waste of time to Tom, Body, Leary. But yeah, I honestly couldn't figure out who was the first person to say touch it, own it. But it's a pretty common phrase in FRC. Let's move on to the next page. Again, there's something other than just being blue and wonderful that all of these teams have in common. They all have continuous roller intakes, right? Every single one of them. In fact, the last time 254 didn't run a continuous roller intake, where they were popularized, and that was the last time they lost SVR in competition, right? Every time they've been at SVR, Silicon Valley Regional, since 2007, they managed to win it. So the last time they lost a regional at all was back in 2012. Team ironic. That doesn't mean Swerve is good. That's just they're a good team.
Yeah. So the basic idea here, this is like a pretty, I guess, design focused, like actual design focused rule. But for all of the previous game elements in FRC, which have mainly been like foam balls, like playground balls, milk crates, like roller wheels as opposed to clamps have generally been the best way to grab onto an object, just through like, I guess, in previous years. But from a strategic perspective, the reason touch it, own it is a rule for design is because you don't want to go somewhere and then not pick something up, which I guess makes sense, right? If you need to pick something up to score it for points, you don't want to go somewhere, like expend time, and then end up not picking it up. Another thing for touch it, own it is it makes autonomous strategy a lot easier. So if you think about the autonomous period, right? At the beginning of every match, the robot has to move by itself without driver control. And that means that if you send your robot to a point and the intake is running, right? If you're off a little bit with the clasp, like a little claw that goes in like that, there's a lot less margin for error than like roller wheels that can take it in. So in general, what the idea here is you're trying to reduce the margin of error that either the robot autonomously, when being autonomously operated, has, or even like when somebody is physically driving it, has to be able to pick something up.
Yeah, before 2007, roller intakes weren't that common. If you go back and look at games back then, they're excruciatingly slow to watch because everyone's just bumbling after game pieces, and no one can get a grasp on them. For like really good drivers, like Nick Hoffman, who's the current mentor of 2056, used to be on 1114. From that period of time, were drivers that could somehow manage to actually get game pieces into their robot. In industrial, right? Generally, you're using a robot arm that's staying still. You don't have to chase things. In competitive robotics, you have a drive base. You can't depend on your location to be consistent. And as a result, roller intakes like this one, 1323, developed in 2018, and then literally everyone copied 973, 1678. The Lightning Turtles, I honestly don't know who they are, and 254. Yeah, they're pretty consistently good at this point in time, to the point where teams have coined them as a strategic design rule since as far as back as like 2012. This is a particularly important, and it used to be controversial. It is almost definitely not controversial at this point. Rule. A lot of people have said it. Steve Jobs said something similar. I think it was like artists develop good things, great artists steal good things. I mean, steal from the best, invent the rest. It's a good rule of thumb, honestly. So now getting into a bit of FRC history. Team 100 from back in 2007 utilized the first really popular roller intake. As in, it put them like miles ahead of the competition. Enough so that the team that eventually took them out, Team 27 Rush, also a top team still in this day and age, they copied off of their roller intake and ran it. And then in 2011, which used inner tubes again, so similar games, repetition, both 254 and 973, who had both been beaten by Team 100 on individual occasions, utilized their articulating roller intake mechanism and just ran with it to worlds. They were the world champions for that year, right? 254 and 973's Robot Titan both ended up winning a championship. Also, don't worry, 973 doesn't run orange now. You'll never have to see that again. My eyes are burning. I don't want to stay on this page any longer.
Okay, so I guess like the core idea there is you don't always have to invent something new, because I feel like I mentioned this before, but there's a lot of like repetition in themes or even like game object types in FRC. It doesn't even have to be FRC. For a lot of the things that we're trying to do in robotics, there are like existing solutions. And just because you're using an existing solution doesn't mean you're not going to learn. You still need to understand how the mechanism works, how to replicate it, how you yourself is going to make it, or yourself are going to make it. So I guess the idea here is that you're not always going to be creating everything from scratch, because you can look to the past and look at things that have already existed and been proven to work in the past and say, hey, I like how that works. Let's see if that past solution can be applied here.
And even better, you can also improve on them. You might note that while 973 pretty much copied directly from 100's design, I mean, they did add pneumatics here to clasp and 254 reinvented it. They used the same basic design, but they functionally a lot. So steal from the best, invent the rest. The second bit is pretty important too.
Yeah.
Oh gods, I hate that 973 color scheme. I get it fit their school colors, but like, oh, that hurts. Fail faster, fail better. Something, Samuel Beckett said this. Yeah, so this is an event that I will look forward to every year going forward. 1678 premiere night. They have it around they run their actual premiere night around week 6, but they do a trailer around week 4 or week 3, where they have a full ridiculous auto to show off, right? In 2019, it was a 2 hatch panel auto, which was one of the top autos. In 2017, they did a gear and 40 kPa auto. You don't need to know what that means. It's just important to know that it was good. In 2018, they had a 3 cube auto. 254 outplayed them with a 4 cube auto, but still ridiculously good, right? So in 2020, they did a similar event, and if you go to the comment, I think it's a nice thing to check out, honestly. Just look at it. But they're all how did you get done with this so quickly? It's kind of ridiculous. At week 4 and week 3, right, we were still designing a robot. And part of that is just we have bad time management. And hopefully we can solve that in the future with better management techniques. But the 1678 philosophy is effectively fail fast. They iterate on it throughout the entire season, but with that drivetrain, they can test autonomous routines. They can build on prototypes. They use entirely VersaFrame, so they can just kind of hodgepodge together something. You might note not even the gussets are aligned because I kind of just threw this on there. They can build really, really fast. And since they can build fast, they can fail fast. Since they can fail fast, they can iterate faster. And that means they get better faster. Again, 1678 has been an Einstein for 7 years in a row now. It's the longest competitive Einstein streak in history. Actually, the second longest was like 4 years in a row, so they completely outplay everyone else. 254, since I need to tie everything back to them, honestly, they're so good that you just can't not tie everything back to them. Yeah, prototype early, prototype well, prototype fast. And this was a championship winning robot. They designed their entire robot around doing a 3-ball auto. And they prototyped it. I think this video they released was around week 2, week 3 when it was taken. So yeah, they build fast. We had effective prototypes, I'd argue, around week 3, week 4-ish. These are teams that have effective robots around week 3, week 4. So fail fast, fail better. Next slide. Keep it simple, stupid. Or maybe keep it stupid simple. Kelly Johnson said one of the two, and honestly, people have been arguing about which one he said for a while now. His biography is interesting. So again, back to 2015, where we started. I suppose that's where we'll end. These are their 2019 robots, 2018 robots, and 2013 robots, respectively. I just picked 2013 so I could fit it into this tiny area that would have been like blank without it. But it's still a beautiful robot, right? I think we can all agree on that. Also, ridiculously simple. 2013 was a year where a lot of teams tended to over-design, because the game elements that year were frisbees. And I mean, frisbees had never been done before in FRC, so everyone was kind of coming up with new stuff. And 2056 played it absolutely brilliantly. This is one of the simplest effective designs to hit competition. And it didn't even do a full hang. They just hung in the first rung. They decided it wasn't worth it to try and go to like higher rungs. You don't need to know what that means. I think it talks too much. Yeah, 2019 robot, highest OPR in 2019. 2018 robot had the second highest OPR in 2018, only behind 254, which again went undefeated for the entire season. No one was going to beat 254, so honestly, it doesn't matter. Just incredibly simple robots, and for the most part, they're also incredibly effective. Now, out of these robots, none of them have won a championship. 2056 has never actually managed to land a champion. And I'd argue the main reason for that is they're incredibly simple, but they're also too simple. Every one of their robots has a notable weakness. Their 2018 robot didn't have a great auto, so they eventually were defeated in Detroit finals by a team that just took the scale in auto and kept it for the entire match. Even with their fantastic scoring abilities, they couldn't win that back. In 2019, they were done in by defense because they just couldn't play around it. In 2013, it was actually their fault that they lost in 2013. So let's just get past that. Our best robots, too, have been some of our simplest robots. Yeah, we had a ball mechanism on our 2017 robot. It wasn't particularly effective. It was just meant for the low goal. But our gear mechanism was pretty ridiculously simple, right? This entire thing is just passive. Gear lands on the top, slides into the area, then we can score it. It's simple, it's effective. Also our most successful season of all time. We versed in San Francisco Regional, along with 971. We made it to championships off a wild card. First, we Alliance captained won. So we did really well in 2017. It's also arguably our most simple design ever. So take that what you will. Keep it simple. Make sure, I mean, technically a drivetrain is more simple than any other design, right? You just toss a drivetrain on there and 0 functions. Wow, simplicity. But strike a good balance between simplicity and effectiveness. The bare minimum to meet your competitive necessities. Yeah. And with that, anyone's got any questions, comments, concerns, tales of woe?
I mean, I'm probably just gonna
add a little.
Echoing.
Yeah, you're back.
Reinforcing subjects, I suppose.
Okay, well, I'll just talk through the echo. Actually, that's pretty annoying.
Oh, I thought he was talking about echoing things I've said.
No, like there's like literally an echo. But so these are all like techniques for designing a robot, right? To try and, or I guess rules that teams self-impose on themselves, so that the product that they create ends up like being something that meets their goals, right? But before like you impose these rules on yourself, one of the most important things to do is like formulate those goals. And I think Sadesh touched on that a little bit at the beginning of his presentation, where he talked about how like our organization goal is having fun, and he qualified it with like saying winning is fun, which I will agree with. But what that means is looking at the rules of the game, looking at how the score is distributed, and then thinking about, so what do we actually need to do in order, and what functions does our robot need to have to score the most amount of points? So what that means is you get the game manual at the beginning of the year, right? And the game manual is basically a list of all of the rules for the game, the parts you're allowed to use, how it works, and how the game is scored. I'm actually going to just drop the game manual for this year and technically next year in the team's chat. And I think it's probably just a good idea to have you guys go through and read some of it, just so, because, well, honestly, I think it's pretty difficult to understand some of the stuff we're talking about, or at least maybe not just right now, but in future presentations, without understanding the game that we're playing. And I guess that same idea, if you don't know what game you're playing, you're not going to be able to play the game very well, applies to your season as well. What you want to do on day one of every season, or I guess every engineering project, I'd say, is pretty clearly define what your problem is. I mean, it's, as you see there, step one of the engineering design process. But specifically in this situation, what your goals are, or how you're going to, like a framework, I guess, for how you intend to solve the problem. That doesn't mean your actual mechanical, what's it called, ideas, or like, oh, we're gonna use an elevator, or we're going to like use pneumatics for this part of the game. It's just like, what will score the most points? For example, in the 2017 game, there were two ways you could score points. You could shoot these little wiffle balls into like a high goal, basically like 10 feet in the air, like a basketball hoop, almost slightly smaller. Or Sadesh, I think, showed a image of our 2017 robots. You could pick up these little gears. They're not really little, like 13 inches, and you could put them on little pegs that were just chilling around the field. And what a lot of teams did on like the first day of the season that year is they read the game manual and they realized, wow, they applied build within our limits. We don't really know how, we haven't built a shooter in a while, and it takes a lot of time to build a shooter that's effective enough that it shoots quickly and accurately. But this gear thing seems pretty simple. They also correctly identified that gears were worth a lot more points than the balls. So what ended up happening in the 2017 season is a ton of teams just straight up didn't like do half of the challenge, like literally, because the other two parts, which were running gears and climbing, were worth way more points. And this didn't really end up becoming a factor until you had like teams that had the ability to be really good at scoring gears and really good at scoring balls. which didn't happen until very late in the season, right? So I guess, like, to sum it up, or the idea there is, what you want to do is when you're reading it, you want to look at the areas or the tasks that you think will give the most points, but also the tasks that you want to be able to complete most effectively. Have, like, I guess, a higher, I would call it an accuracy rate, but it's not really accuracy, completion rate. Because if you're throwing balls up, right, into the air, and each one gives you, like, 1 point, and, like, a basketball hoop from your robot, that takes a lot of precision, takes a lot of accuracy. If somebody plays defense on you, then it gets even harder. Compared to if your strategy is running gears and then just shooting at the end, you're going to score a lot more points with the second option. So on day 1 of the season, what you should be able to identify is, hey, this task is more important than this other task. I just realized my camera was off. Okay, like, this task is more important than this other task. You want to create, like, a priority list of, like, hey, this is what we're going to work on, and then this is what we're going to work on. Not really, like, chronologically, but what you want to prioritize in order to make sure that your robot's the most competitive. And quite honestly, that's an area that we haven't really succeeded in previously with, like, keeping up with our prioritization throughout the season. Because every year, we, like, pretty rightfully prioritize our end game objective, right? Which usually ends up being climbing. Because those end game objectives in every game usually give a lot of points and are necessary for a ranking point, which I think we talked about last time. But ranking points are like a special type of point used in, well, ranking at competitions. And these are all the types of things that you want to consider even before you start brainstorming multiple ideas for each challenge. You want to consider the relative importance of the challenges and how much, I guess, basically like a cut list almost, but in reverse. The functional baseline that you're hoping to achieve to be competitive is what you want to have. Yeah. I don't know how many people have had the opportunity to, like, start reading through the game manual. I just realized I was gonna, like, tell you which sections to read because, like, it's like a 135-page document, and most of it isn't really relevant to what we're talking about right now. The only section that you, like, really need to read is section 4, which is about match play, just, like, how the game is played, and if you really want to, like, game rules, which is, like, sections 7 and 8. So what happens on kickoff, which is the first day of the season, is we all sit down and the code for this document gets dropped, and we literally sit there for like an hour or two, all reading, pointing out differences year to year, pointing out quirks on how to score, all that kind of stuff. And we just try and create a strategy, right? An example of what we did this year. Oh, okay, yeah. Parts letting me know something that's pretty important, which is you should also probably familiarize yourself with the robot construction rules, although I argue that's, like, not as important right now. We're just talking about strategy and how that plays in. I feel like I've covered a lot about how strategy works, but let's just look at an example. Last year, 2020, right? We got the game, and then we looked at the scoring, right? And one thing we pretty immediately realized is, like, hey, hanging gives a lot of points, which is 50 points per robot. Wait, that's 25 per robot. I'm tripping. But 25 points per robot, whereas each ball in the upper goal gives 2 points. And because you're only allowed to have 5 balls on your robot, that means that a robot would have to go back and forth at least 3 times to score as much as just one hang. So what we realized on day one was like, hey, hanging is important. It's worth a large part of the points share. And when we went to competition, our first competition at Canadian Pacific, I guess our first and only competition, we found out that that was like very true. Because when you're like at an early competition, right, the scores aren't going to be very high for like the major game task, which is like, once again, shooting balls into a goal, right? A lot of teams hadn't figured out their intakes properly, or their shooters weren't tuned. So the scoring wasn't very high in terms of balls. But a lot of teams had really high hang rates, and the teams that were hanging every match were the teams that were usually winning, because they were able to consistently score that 25 points. And a hanger isn't really the most complex thing compared to a shooter. It's a simple elevator. It's at its base level like a rope and 2 bars if your robot's pretty light. So I guess the major point is you want to, when you're looking at a game manual like this, for strategic design, your goal is to determine what's important, what's going to score you the most amount of points, and then a very important part is once you've determined what's important, you need to emphasize those important tasks in your building process later in the season, which is somewhere that we usually, that disconnect there is something that we've had an issue with in the past, where we like correctly determine like, hey, this task is really important, and then we don't give it the proper importance in terms of sub-team delegation or making sure that we have the parts necessary. But yeah, I guess that's my take on what strategic design is for a team, or what you guys need to know about strategic design. Are there any people that have questions about, I guess, design, and if not strategic design, just in general questions about what we're going to be doing in CAD/design this semester and like future talks? I know this one was like a really long lecture style format, and probably for some of you, like it wasn't that engaging. And I promise that we're going to be doing some lectures, but a lot of our stuff is going to be hands-on. I know next meeting, we're going to be starting setup for Autodesk, and we're going to start teaching Autodesk Inventor. Also, what that means is you guys should probably get Autodesk Inventor. I know some of you probably only have Macs, and if you have a Mac and you don't have Boot Camp, you can use Fusion 360 instead of Inventor instead. Oh, I guess I should probably explain what Inventor is. I assume everybody know. But so Autodesk Inventor is the tool that we use for CAD, our computer-aided design. So before we make all of our parts, we model them in Autodesk Inventor, so that, I mean, first we do sketches so we can see like, hey, this is like the geometry that we're going to use for our robot, and then we like turn them into 3D so we can like put them together, make sure nothing's interfering with each other, and that like we have a robot that can physically exist, and then we send it to the machine shop, right? So what we're going to be working on over the next couple of weeks is teaching you like basically how to draft, like how to take something that already exists and turn it into like a 3D object that exists in CAD. And then we're going to teach you about how to make your own things like that you're thinking about, and CAD those. So Autodesk Inventor is free for students. So I'm just gonna send the link to Inventor. I know it says download free trial, but what you want to do is basically make a student account using your Warrior Life email, and then what's it called? you should have the option to get a 3-year license for Autodesk Inventor Pro. I would say please get 2020, mainly because usually what we do on our CAD team is like we stick with the version for a couple of years, so we don't have to deal with like backwards compatibility issues every year. And we just recently switched from 2018 to 2020, so we're probably gonna be on 2020 for like the next 1 or 2 years. So yeah, before next meeting, install Autodesk Inventor 2020 Professional on your home computer of choice, so that we can teach you about how to make parts. And by parts, I don't mean like actual parts. That's just like the term for a basic, like, I guess, single unit inventor.
Hey, Kashyap, can I add something in here too?
Yeah, go ahead.
Just for anybody that hasn't used Inventor in the past, is very new to Inventor. One thing you can do to give yourself a head start, because it is difficult to, just in a few lectures to teach a comprehensive CAD software like Inventor. I would recommend, if you have a library card, I'm not sure, I know at least for Santa Clara County, if you have a Santa Clara County library card, you can get free access to lynda.com, lynda.com, which is, it's now owned by LinkedIn Learning. But they have, it's really, as far as tutorials go and trainings, it has a really comprehensive video training series on Inventor. I mean, that's honestly how I learned how to use Inventor and CAD, and like it goes through kind of all aspects of it. So you can go through those videos, kind of follow along. You get like you get free premium access to Lynda, so you can get files, example files and stuff to download and look at. But the videos are all broken up into like a few minute videos or 5 to 10 minute videos, really quick and easy, so you can go through a few. But it gives a really comprehensive overview and detailed introduction to every aspect. I still honestly, even though I've been using Inventor for years now, there might be some I like forgot, but I know it's in one of those videos, and so I'll go back to one of the sections, on assemblies or something, just to see how to do that one thing. And it's great quick reference as well. So if you have a San Jose library card or any Santa Clara library cards, you can get free access to it. And I can post like the link to log into that in the chat here using your library card.
Yeah. In general, video tutorials are really helpful for trying out new features in Inventor. I haven't heard of lynda.com before, but from what I can hear with Mr. Huber, it sounds like these are like professional videos that have really helped him. So this seems like a video resource that would be like even more helpful than just like random YouTube videos. It seems like a structured curriculum. And while we will try to cover as much as possible in our lectures, Mr. Huber is 100% right when he says in like our several days of trying to teach Inventor, there's only so much we can do. And I will say that most of the learning that you're going to be doing when working with Inventor is going to be, you're working on a project, you're like, oh shoot, how do I do this? And you like look it up and you try something, and that kind of works. But then you realize later on, oh no, if I keep doing this, it's like unsustainable. So let me go back and try something else. And you keep trying out different features, and you'll eventually learn the best practices. Although the goal of our, I guess, series is we want to try and, I guess, teach you some of those so that you don't necessarily have to go through the process of like learning some of those yourself, or I guess also teach about how we in general, like our practices for CAD, that we found are pretty helpful. I mean, overall, like that was our strategic design presentation, and that's what we're planning to do in future meetings with Inventor. So I'd say if nobody else has questions, Siddesh, you can probably stop recording.
Will do. Stop recording. I also recommend, if you are